Ladies and gentlemen, welcome to another video. In this video I'll be talking about another important construction material that's used in a lot of structures, and that is masonry. So the learning outcomes for this video, hopefully by the end of the video you will understand what masonry is. We'll have a look at the history of masonry. I'll be talking also about some of the materials that are used in masonry units and blocks. I'll also discuss some design aspects involved with masonry structures. I'll go through the types of masonry units, and then finally I'll be talking about bonds in masonry structures. So first off, what is masonry? So masonry involves building of structures from individual units that are laid in and bound together by a mortar. And the mortar over here is grout. It's mostly used for walls, specifically retaining walls and external walls. You can also find structures such as columns that are built from masonry. In terms of its durability, it's very durable. Depends on the quality of the masonry units that you use. It also depends on the mortar that bounds together the units, and also on the laying pattern. So the history of masonry has a very interesting history. It started off in ancient Egypt, 2600 BC, with the pyramids. So the pyramids, they're composed of masonry units, and these pyramids were constructed through stacking of limestone. So the masonry units were limestone. We also see examples in China, for instance. The Great Wall of China was constructed using masonry as a material. And then in the Middle Ages, talking about between the 5th to 15th century, stone became very frequently utilized to build massive structures such as castles, bridges, cathedrals and mosques. Examples are, for instance, seen in Andalusia in Spain, where massive structures were built, massive mosques, as you can see in the picture in front of you. The reason that people like to use stone was because it was a very durable material. So it was able to support much heavier superstructures, and that's why it was very well suited for cathedrals, for bridges and for castles back then. And then came the Industrial Revolution. Now with the Industrial Revolution there was technology that started to be utilized in the construction process. It was easier now to quarry your materials, it was easier to transport these materials, and so you ended up with more elaborate structures. It was more of a systematic way of building, and the utilization of stone started to fade away. Now at modern times, what we see now, it's very rare that people sort of use masonry, and the reason for that is because it sort of lost its shine in the late 19th century due to all that technology that was present. Plus it takes ages to actually build a structure from masonry. It's very intensive in terms of labor, very expensive, and so nowadays you see a lot of the houses or a lot of the buildings are built using, let's say, timber or metal frames instead of masonry. When you do see structures nowadays that are built from masonry, what we notice is that they use concrete blocks, and so these concrete blocks become the most common unit in terms of a masonry structure. Sometimes also you need to reinforce the structure, and hence you would embed steel within your masonry units. So in terms of the materials, what's a masonry structure composed of? So these units that you put together in order to build your masonry structure, they can be composed of one of four main materials. Number one, which is the most common, clay brick. Number two, stone. Number three, concrete blocks. And number four, calcium silicate. Let me go through each one of these now. So clay bricks, as the name implies, they're made from burnt clay. They're used in general works such as walls, specifically non-load bearing walls, including fences, and sometimes some facades of buildings would be constructed from clay brick. In terms of the size of the brick itself, it comes in a standard block size in Australia, and the size is 230 by 110 by 76. You also have to consider 10 mil of mortar joint, and so you add 10 mil extra to the dimensions of the brick itself, so your overall working size becomes 240 by 120 by 86. The brick is given a classification based on how it is laid and how the exposed face is oriented relative to the face of the finished wall. Now, in the image that you see in front of you, these are some of the common sort of orientations of bricks on structures. So if you're considering a wall, for instance, some of the common orientations that are adopted include the stretcher orientation, the header orientation, and the soldier orientation. Now, moving on to concrete blocks. So your masonry structure, as I said, can be composed of several materials. We talked about clay bricks, and now I'll be discussing concrete blocks. These are units made from concrete. They have a very large loading capacity. So concrete is really strong in compression. In terms of the finishes, it's actually a very high aesthetics that are associated with structures built from concrete blocks. Very smooth sort of finish, and they have a high fire resistance. Now, in some instances, you also have these blocks reinforced through the use of steel reinforcement. The last type is the calcium silicate brick, and this particular brick contains a high amount of sand, so we're roughly talking about 88% to 92% of the overall composition of the brick. Pigments are also added to get various colors, as you can see in the image in front of you. Now, a very big advantage of the use of calcium silicate bricks is the fact that they do not absorb much heat from the sun, so the solar heat effect is reduced, and it means that it's very suitable for use as a material in hot climates. Less mortar is also required, and in addition, there's no need for a finish. So if you consider these two aspects, the fact that you need less mortar and the fact that there's no need for a finish, it's a very cost-effective material to adopt for your building. Now, masonry design. What's the design process that's involved when it comes to masonry structures? When you want to design your structure, the first thing that you would need to consider is the type of the masonry unit. Now, the Australian standards, they specify a number of types that are associated with masonry units. The Australian standards that I'm referring to over here, that's AS 3700. And some of the types that it gives for the masonry units includes the solid type, and that's mostly masonry units that are constructed from bricks. You have the cord type, again that's mostly bricks. And you also have your horizontally cored type, and that's where you have your cores on the side face of the block. Again, it's mostly bricks. And then finally you have your hollow unit, and that's mostly your concrete blocks. So these different types, they come in different sizes, and the reason that you get different sizes is because, number one, your requirements in terms of load capacity of the actual unit. Number two, for aesthetics reasons, so if you're trying to construct a structure with particular features, you might need units or blocks of a specific size. And number three, applications. So constructing, let's say for instance, a wall from masonry, if that wall is load bearing, then there's going to be a different sort of unit block that you have to utilize compared to a non-load bearing wall. So the good thing about masonry is that you can sort of construct walls and structures of various forms, and you can see that in the image in front of you. So a lot of people have this common misconception that you can only use it to build either a horizontal or a vertical structure. But whereas you can see in the image, for instance, if you wanted your wall to have this spiral pattern to it, then you can actually achieve that with masonry, although it does require a bit of an effort. The design process, as I said, it's controlled by the AS3700. So AS3700 gives us guidelines, especially for the structural engineer when it comes to the design of a masonry structure. Table 3.1, what you see in front of you on this screen, gives the strength of the masonry unit. And it does that through looking at the type of the masonry that's used. So depending on the material of the individual units, clay, concrete, etc. It also lists down the strength subject to the bedding type. The bedding type impacts the strength of your masonry structure. And when I say bedding type, what I'm referring to is the sort of the masonry structure as a whole interlocks together. So these units, they interlock to form the overall structure because of the presence of the mortar. So the mortar that surrounds these individual units, this is what is referred to as the bedding of the masonry structure. So depending on the mortar type that's used within the masonry structure, you will sort of end up with a different strength for your overall structure. A face shell that's mentioned in table 3.1, what that refers to, it refers to the mortar that just covers the face of the brick, as opposed to a full mortar. And then finally, the mortar class. So there's 3 classes in Australia: class M2, class M3, and class M4. And these classes, the reason that you have different classes is because it depends on the amount of limestone that's actually present in the mortar. For durability, table 5.1 gives us some guidelines when it comes to assessing the durability of our structure. So what it looks at, table 5.1, is it looks at the exposure environments of the structure. For instance, are you going to be building your structure close to the coast? Is it in an industrial setting, or is it sort of in a climate that's mild temperate? So these various environmental exposures, they lead to different choices in terms of the mortar type that you choose, or the type of units that you adopt for your masonry structure. The table also helps determine the reinforcement cover, and reinforcement cover is important if you have, let's say for example, a concrete block forming your masonry structure. Now, if you're trying to avoid corrosion, let's say for instance of the steel reinforcement, to enhance the durability of your structure, then an important consideration will be the reinforcement cover. So as I said, there's 3 types of mortars that are available in Australia: type M2, type M3, and type M4. M2 is mostly used for external structures that are above the ground. So for instance, walls. You can also have M2 being used for internal structures. So if you've got an internal wall, not necessarily external, that's non-load bearing inside the building, then you can utilize M2 as a mortar type. Type M3, again, you can use it for external structures that are above the ground, so walls that are load bearing. And over here I'm talking about a structure that's positioned 1 to 10 kilometers from the coast, and that excludes retaining walls or any walls that are beneath the ground. And walls that are also in contact with fresh water, you can actually utilize mortar type M3 for such walls. And finally, type M4. So type M4 you can now use for retaining walls, so walls that are beneath the ground. And you can also use for external walls that are above the ground. even if these walls are sort of within 1 kilometer from the coast. In terms of the types of masonry units that you have for these mortar types, you can get all types of masonry. So you can have clay, you can have concrete, and you can have limestone that's utilized with any of these mortar types. Now, when it comes to design, another important aspect is the detailing that's involved. So when I say detailing, I mean how the reinforcement, if you have a reinforcement embedded in your masonry structure, how that links to other members. So in the example that I have on the slides, you've got a foundation system with embedded reinforcement. At the same time, you're constructing a wall. So let's say, for instance, a retaining wall above the foundations. You have to link the reinforcement that's inside the masonry structure to the reinforcement that's embedded in the foundation system. If you make sure that you have the correct connection, so if the connection is done in the right way between the reinforcement, then you ensure that your structure is durable, and that's why it's important. The core that you see in a masonry unit, it's actually empty. So you place your steel rod in it, and then you have to fill it with grout in order to make sure that the reinforcement becomes part of the overall structure. Again, if you have a situation where you've got a masonry structure and then an opening beneath it, so for example, you have a wall and then you have a door that's sort of surrounding that wall, then you got to make sure that any part of the wall that's above that opening, it has to have extra reinforcement, because you're removing part of the wall to allow for a door or for a window, for instance, in that space. So you got to reinforce that with steel to carry the stresses, and that's an important part of detailing these masonry structures. A huge advantage of masonry structures is when it comes to fire resistance. Now, the reason for that is because of your double brick construction. When you have double brick construction, so let's say, for example, a double brick wall, you have a cavity between the two walls. So that cavity, as you can see in the image in front of you, it has the advantage of acting as sort of an insulator when it comes to fire. At the same time, you can utilize that space to, for instance, add an insulating material to ensure thermal comfort in cold climates. Okay, so now I'll be talking about the brick bonds, and this is very important because, as I said, the strength of the structure depends on how you lay out the individual units within that structure. So when it comes to brick bonds, there's a uniform sizing of the bricks, and that helps create a regular and a repeatable pattern. And you notice that when you look at any masonry structure, you do notice that a repeated pattern that is often very visible. So this is what I'm referring to over here as the brick bond. It's that sort of pattern that repeats. And the reason that we have this pattern is because it allows the interlocking of each row of bricks or concrete blocks so that you reach the desired capacity for the overall structure. Now, in Australia, we have 4 common brick bonds. Number 1, your running bond. Number 2, the common bond. Number 3, the English bond. And finally, the Flemish bond. I'll be talking about each one of these next. So let's start by looking at the running bond. For the running bond, which is the most common type of bond in a masonry structure, what you have is what we often refer to as the 1/2 pattern, and that is where you have one brick that supports 2 bricks above it. So looking at any one row in the wall, there are bricks staggered by half a brick from above and below. This pattern repeats itself, so you'll constantly notice within the whole structure that there's one brick that supports 2 bricks above it. The common bond is another common type of bond that you see in masonry structures. It's similar to a running bond in the middle of the wall. The difference here is that some of the rows, they have bricks that are laid in the header orientation. These rows with a header orientation, they take place every around 5 rows. And if you have 5 rows of running bond, followed by a 6th row that is now the header orientation, that's how you know that you've got a common bond pattern in your masonry structure. And this sort of pattern repeats itself. So you have 5 rows of running bond, and then your 6th row would be one where the orientation of the brick is in the header orientation. The English bond, again, you see some buildings that adopt this sort of pattern. It's similar to the common bond, but over here you have the header orientation row that's adopted every other row. So instead of every 5 rows, you have a header orientation row that's adopted every other row. Finally, the Flemish bond. This again is a pattern that you visibly see in a lot of masonry structures. And over here, each row is composed of a stretcher and then a header. So you have a stretcher, a header, a stretcher, a header, and so on for each individual row in the overall masonry structure. So that was it for this video. I do hope that the video helped clarify some of the details that were involved with the construction of masonry structures. If you did enjoy the video, please do check out my other videos where I talk about other construction materials.